Hey, this is Mr. J. Let's go through this multi-step trig problem. We're going to take this given information down here and we're going to put it on the graph, right? And we're going to figure out what all the missing sides and angles are, and then we're going to go calculate the area of the big triangle. So the big triangle we're really starting with here is ABC, like that right there. And I've dropped this altitude, from here, from C to D, right? This imaginary line. And that creates two separate other triangles. You have this small right triangle here, right, because we're going to drop it where it's perpendicular, and you have this medium-sized triangle, and then you've got the one that's the original big triangle we're going to find the area of. All right, so we're given some information here, so let's put that on the graph. Angle ABC, so this angle right here is 80 degrees. Angle BCA, which is down here, is 70 degrees. Well, let's go ahead and find angle A. Well, angle A, of course, is going to be 180 minus 80 and minus 70. So that's, what, 150 from 180, so it's 30 degrees. All right, so we know that right there is 30 degrees. And we'll use that in a minute, probably to find the length of AC and AD. All right, so back over here, we've got this right angle here. And let's go mark up from this angle, which is going to be our reference angle here. Let's go mark up the hypotenuse. Here's the hypotenuse, right? And it looks like that hypotenuse is given as 5.5 centimeters, all right? So we're given one side. So in order to solve trig problems, we usually have to be given an angle and at least one side, and we can rock and roll from there. Okay, so it looks like what we're trying to find here is the opposite side. Remember, here's the hypotenuse, and the adjacent side over here, which is going to be this really small side right there, dB, is going to be the adjacent, and so it looks like we're looking for the opposite. So if we're looking for the opposite, we know the hypotenuse sounds like that sine, so we're going to do sine of 80 degrees is the angle coming in, looking for the opposite over 5.5, which is the hypotenuse. Remember, when you're missing the side of the top, it's just going to go straight to multiplication, so the opposite side there is going to be equal to 5.5 times sine of 80. And when you run through that run that through your calculator, it looks like that the opposite side, or the altitude, is 5.42 centimeters. So let's go ahead and put that on the graph. Okay, 5.42, like that right there. So let's go after the adjacent here. All right, so if you're looking for the adjacent and you know the hypotenuse, that definitely sounds like cosine. So let's do cosine of the same angle is equal to the adjacent, ADJ, and we're looking for, and we have the hypotenuse. Same thing here, we're missing the side of the top, so the adjacent is simply going to be what? Is going to be 5.5 again times cosine of 80 degrees, right? And it looks like that it's going to be really small side, which is going to be 0.96 centimeters. So that right there is 0.96 centimeters, okay? All right, so moving along, let's erase some of this right here. Moving along, let's go after this side over here, AC next, okay? So we know that from angle 30 degrees, now we're going to switch over to this other angle. From angle 30 degrees, we know what the opposite is, because that right there is going to be the altitude, and it looks like we're finding the hypotenuse here, and the adjacent we'll find in a moment. All right, so if you know the opposite and you're looking for the hypotenuse, then we're going to do sine, right? So we got sine. Now we're changing gears to 30 degrees, right? All right, so in this case right here, you have the opposite, which is that right there, and you're looking for the hypotenuse, right? All right, remember, when the missing side is in the bottom, you're going to have division. So the hypotenuse is simply going to be, right, 5.42 divided by sine of 30 degrees. And when we run that through the calculator, it looks like that turns out to be 10.84 centimeters. All right, so that's 10.84 centimeters. So we found that side right there, and so we got to do one more side, and let's find the adjacent here using 30 degrees again. So if we're looking for adjacent, we know the hypotenuse, then we're definitely going to do cosine, right? So we're going to do cosine of 30 degrees again, using that there. So that's going to be equal to the adjacent, which is unknown, over the hypotenuse, which is 10.84, right? And so in this case right here, it's going to be multiplication. So the adjacent is going to be equal to 10.84 times times, right, cosine of 30 degrees. We run that through a calculator. It looks like that we get 9.39 centimeters, right? So 9.39 centimeters. So it looks like we have everything that we did not know from the beginning, which is all the angles. You've got 80, 70, and 30 degrees of the angles. You've got 5.5, 5.42 for the altitude. You've got 10.84 down here. You've got 9.39, and you've got that little 0.96 centimeters. So let's now then find the area of the big triangle. Okay, so that's going to be the area is equal to, right, the base times height divided by the 2. Well, remember, it looks like that the base is divided into 2 pieces. So we're going to have to say, open parentheses, what do we got? 9.39 plus the 0.96, and then we're going to multiply that times the height, or altitude, which is 5.42. And remember, we always got to divide it by 2. That's the easiest thing to forget, right? Okay, so we got to add that together right there first. Then we got to multiply times that, and we divide by 2 at the very end. And it looks like what we come out with is 28.05 centimeters squared. Okay, so again, this is multi-step. It's a lot of different regular trig problems. We've got to be able to make sure that we can identify our usual opposite, hypotenuse, and adjacent sides. We've got to be able to recognize that 3 angles inside of a triangle equal 190 degrees, and we've got to be able to set up all of our ratios right, and then at the very end we've got to make sure that we find the area of the triangle correctly by identifying the 2 pieces that make up the base, multiply that times the height, and divide by 2, and we get the area there. Thanks.